Good morning, good afternoon, everyone. I'm Dr. Sridivya. Uh, so today we will be knowing more about the water and wastewater treatment technologies. All right. So last class we have seen several aspects regarding the flow of water, water quality, its analysis, and everything, and stages to different stages of treatment and all that. And today we will be learning more about this type of aeration and all. Sorry, aeration. Have we discussed it before? All right. Today we'll be learning more about filtration. With this is also one of the type of biological treatment process. All right, mainly used for the water treatment, and we will see what it is exactly. So this filtration mainly it is of rapid sand filtration and slow sand filtration. These rapid sand filters are the coarse sand materials which are mainly used for the filtration medium in order to remove the suspended solids from the water, and also the turbidity of the water can be removed. It is a basically a pre-treatment step prior to the final disinfection process such as chlorination process. And these rapids and filters are we have, like for example, we have the additional advantage that they have often already present in the conventional drinking water treatment plants, to majorly to remove the inorganic and organic compounds and residual particles present in the water, mainly with the remnants after the upstream processes such as aeration and coagulation. So initially there will be aeration process, then the process called sedimentation process, as we have seen earlier, by screening and all, by using the coagulants, flocculants, and all these. The main suspended particles will be setting down as a grit particles, which will be useful, which can be later removed as a grit sludge, or the sludge can be removed and reused for other processes or directly used for the environmental processes. So in these rapid sand filters, mainly the purpose of this is to mainly removal of the suspended solids, and the main goal is to eliminate the particulate matter that is mainly causing the turbidity in the water, which also includes things like silt, fine organic matter, clay, and some other precipitated substances. These will be included in the soil bed in order to remove the suspended solids. And for the clarification of the water, that is, by removing the suspended solids, the water becomes significantly clear and more aesthetically pleasing. That is for eye, particularly because it is not turbid anymore and it is very clear water, and it is like by the removal of the suspended solids and the pre-treatment of disinfection. um, it is mainly used as a pre-treatment for disinfection. That is, the this rapid filtration is primarily used like a chlorination process, mainly the by removing the particles, which improves the effectiveness of the disinfectants, as they can target the microorganisms more efficiently, and also the enhancement of water quality overall. All right. So filtration is a fundamental separation process which plays a major crucial role in scientific, industrial, and everyday activities and applications. And essentially, it is the process of separating the solid particles, as we have seen in the earlier slide, from the fluid, liquid, or gas by passing through the mixture of filter medium. And the main goal of the filtration is to isolate the solid particles from the fluid. This is mainly achieved by using the filter medium, And the filter medium is a major key component, and it is made up of porous materials such as paper, cloth, or stand. Membranes with microscopic pores that is less than zero point 0.2 micrometers, and the granular substances such as gravel and gravel and activated carbon are the main granular materials which are used for the filtration purposes. And the major driving force of these sand filters are for the filtration to occur is to push the fluid through the filter medium. All right. The main driving forces include the gravity pressure. So this is more economically useful and widely applied externally. Like it is applied as through gravity only. The soil pores through the soil pores, the water will be infiltrated, and the vacuum centrifugal force is also used. Either it should go through the gravity pressure, naturally through the gravity it should go through the soil or the filter medium, or through vacuum, that is by using some centrifugal force or the pumping source, the water has to be infiltrated through the soil. And the mechanism or the way the particles are removed will be varying. All right. One is the straining. Straining is the physical blockage of particles which are larger than the filter pores. Adsorption. Adsorption where the particles adhere to the filter medium surface. Alright. And the sedimentation where the particles settle down within the filter at the bottom. And the biological action where the microorganisms within the filter break down the particles and remove the particles by consuming and lowers the contamination levels. And there are different types of filtration process. One is the gravity filtration where mainly the process relies on the gravity in order to pull the fluid through the filter. And the pressure filtration, which mainly uses the applied pressure to force the fluid through the filter. So we will be applying some kind of centrifugal force, or the pressure pump, whatever it is, we will be applying it in order to force the liquid to pass through the filter. Vacuum filtration where the vacuum is created to vacuum is used to create a pressure difference, pulling down the fluid through the filter. All right. Other one is the membrane filtration, where it uses the thin membranes, ultra membrane, nano membranes. All these are also used with the precise pore size, very minute in size, zero point 0.2, zero point 0.1, not 1 micron in sizes. So these kind of sizes will be used for separation of the solids and all. And the rapid sand filtration is the process which is used mainly in the water treatment sectors, and where the water is passed through the sand filter at a relatively high rate. Whereas the slow sand filtration is used for the water treatment as well, but the water is passed through the sand as much at a much slower rate. So basically, this slow sand filtration is like takes a lot of time, and it is a natural process where it will take like ultimately longer time in order to receive much clear water and all. So the main principles behind this rapid sand filtration are the physico-chemical and biological. And the main physical principles are the straining. Straining are the ones the particles with larger pore size are trapped between the sand grains and physical, trapped between the sand grains. And this sand bed acts as a sieve to prevent the particles from passing through. Second is the sedimentation process. Within the filter bed, the velocity of the water decreases, allowing the heavier particles to settle down. And the absorption particles, where the particles with the even smaller ones can adhere to the surface, like it gets stick to the surface and of the stand grains due to the electrostatic force and other chemical attractions. So it is very important for removing very fine particles and some dissolved substances. And biological principles. So biologically, the biological actions takes place with the help of microorganisms, and hence there will be a biological layer called as a biofilm. So all right, so there will be a layer of biofilm, that is a very thin fine film which is formed due to the activity of microorganisms, and the contaminants which are taken up the microorganisms, they will be trapped there in the biofilm itself. And it mainly forms on the surface of the sand grains, and this biofilm consists of microorganisms that consumes the organic matter and other pollutants present in the water. This biological activity plays a significant role in removing bacteria, viruses, and dissolved organic compounds. All right, the biological activity plays a significant role in removing bacteria, viruses, and other dissolved components. And what are the main key factors and considerations for this rapid sand filtration? Mainly involves the filter media. This filter media characteristics of sand, such as the size of the grain, the human uniformity of the sand, and it is mainly crucial for the effective filtration process. And multimedia filters as well, which combine the layers of different materials like anthracite and garnet, which can further enhance the filtration efficiency. Another key factor is that the filtration rate, where the rapid sand filters operates at a relatively high filtration rate compared to slow sand filters, and which allows the higher throughput of water, but it also requires careful control to maintain the effective illusion filtration. And backwashing, so backwashing also allows the factor, which is another factor, which allows the filtration easier, and it also prevents the filter bed from becoming clogged. So there is a biofilm formation biologically, or there is a formation of clogged materials on top of the soil, and through the process of backwashing, it is previously like filter bed is washed such that the pores are not getting will not get clogged, and sediments can easily pass through the filter media. This mainly involves the reversing the flow of water to flush out the accumulate particles. If the process of flow will be from left to right, for the backwashing it will be from the right to left, in order to reverse the flow to flush off the accumulated particles. All right, and the next one is the pre-treatment. Pre-treatment is that it mainly acts as a pre-treatment, where rapid cell filtration is often preceded by pre-treatment processes like coagulation and flocculation. So once the material is like sedimented by through the coagulation process or the flocculation process, then the water is sent through this rapid sand filtration, where the fine particles also can be removed through this process. And this process also helps to clump together the fine particles, making them even more easier to remove during the filtration process. And then in this rapid sand filtration, the filter media plays a major role, which is a material through which the water passes in order to remove the impurities. So let us see what are the types of filter media present. So filter media basically, the word itself says the rapid sand filtration. So the filter media could be the mainly the sand. Sand, as in it is a traditional and common material oftenly found and mostly used, and particularly the silica sand is widely used due to its availability and durability, and also the cost efficiency. And the main characteristics of the silica sites would characteristic would be its effective size, that is the grain size that controls the pore spaces, yeah, and its uniformity coefficient, a measure of the, that is the mainly the range of grain sizes, the. And anthracite, it is a type of coal which is mainly used in the combination with sand in a dual media filters, and because of this the water will be thoroughly infiltrated and filtrated, and it will be used for the potable purposes as well, and it is mainly lighter than the sand as well, and it forms the top layer that removes the larger particles, and this extends the filter run times, and improves the particle removal. So several times the water can be filtered through this anthracite, which is lighter than the sand, and such that tiny particles also can be removed through this. Garnet. Now, what is garnet? It is a dense, heavy material that is sometimes used in the multimedia filters. So basically, for a cheaper treatment purposes and all, only sand and anthracite can be used. But for the multimedia, for the fresh, very pure water, or if there is a totally gray water, several media filters are required for filtration purposes. Where in this purposes, garnet can be used, and its high density allows it to form a bottom layer that removes very fine particles. All right, this garnet allows the bottom layer to form in the bottom layer particularly, and other media such as the GAC, that is granular activated carbon, which can be incorporated to remove specific contaminants such as organic compounds. And the main key characteristics and functions of these are the particle size and distribution. So it is all about the sand size and distribution, the filter media particularly. All right. So the size and distribution of the media grains determine the size of the pore spaces, within which in turn affect the removal of particles. Mainly the porosity. So porosity is the spaces between the particles, that is the mainly the amount of void space is nothing but the air gaps what we have, in the between the soil and all. Okay, the soil sorry, the amount of void space between the media grains, and the porosity also affects the flow rate and the head loss through the filter. And coming to the next one is the surface area. A larger surface area provides more sites for the absorption and biological activity. And specific gravity, that is the density of the media, which affects its behavior during its backwashing. So there is a due to gravity only the water will be getting infiltrated to the sand filters, right? But during the backwashing it is reverse. And the chemical inertness, that is the media should be chemically inert in order to avoid leaching of contaminants into the water. Alright, so there should be intactness between the soil, between the grains, intactness between the spaces, such that the water should not be once the contaminants filtered through the filtered bed should not be leached into the water, such that there is no point of even doing the filtration, right? Yeah. So coming to the functions of the filtration filter media. So what is the main function of it? The physical straining, that is remove the suspended solids by trapping them in the pore spaces. Adsorption, where removing the dissolved substances by adhering them to the media surface. Biological filtration, growth of microorganisms to remove the organic matter. And the multimedia filters. So they were like by using the garnet and all this. A top layer of anthracite, the middle layer of sand, and the bottom layer of garnet makes this a multimedia filters. And coming to the hydraulics and filtration, so there is a flow of water through which that is the dynamics of it is called hydraulics. And to understand the hydraulics of the filtration, it is mainly essential for designing and operation of the efficient rapid sand filters. And it majorly involves the analyzing the flow of water through the filter bed and the associated pressure changes. And the Darcy's law, first one is the Darcy's law. So this Darcy's law mainly describes the flow of fluid through the porous medium. It also states that the flow rate is proportional to the hydraulic gradient and the permeability of the medium in the context of rapid sand filters. And this law is also used to calculate the flow rate and flow rate of water and through the filter bed, and head loss that occurs. And head loss is another law where head loss is another major thing where mainly the hydraulics of filtration takes place. That is, the water flows through the filter bed, right? It encounters the resistance from the sand grains, leading to the loss of pressure, which is known as head loss. And it also increases. It increases as the particulates accumulate in the filter bed, and reduces the pore sizes. So the pores where there are, like if there are more number of void spaces, more number of pores will be present. When there is a head loss, maximum head loss increases the reduction of the pore sizes will be observed. And monitoring of the head loss is very crucial in order to perform the back washings. And the major factors that are used as an effect of head loss are the filter media size and gradation, and filtration rate, water viscosity, and particle accumulation. And coming to the filtration rate, all right, so filtration size, porosity, all this we have learned in this previous slide, whereas now we will be looking into the rate of filtration. The rate of filtration is the volume of water that passes through a unit area of a filter bed per unit time. It is a key design parameter that affects the filter performance, and the filtration rate can increase throughput, but it can also be leading to the increased head loss and reduce the particle removal efficiency as well. So majorly this filtration rate is affects the filtration performance, and it can also increase the throughput, and which ultimately leads to the increased head loss and reduced particle removal efficiency. Backwashing hydraulics. So backwashing is the one which removes the clogging effect in the filter bed, and majorly it involves the reversing the flow of water to clean the filter bed, and the backwash rate must be sufficient to fluidize the filter bed and also to remove the accumulated particles. The key hydraulic consideration during backwashing includes the backwash flow rate, the bed expansion, water wash through design, water wash troughs, sorry, the water wash troughs design, and these are the main hydraulic consideration. All right, and then the under drain system, how the water is collected from the bottom, how it is getting filtrated, and how it is getting distributed, and how it is getting back while the water is backwashed. So all these takes place in the under drain system. All right, it is the design very crucial and critical for ensuring the uniform flow of water and distribution and preventing the media loss. And hydraulic consideration for the under drain systems. So mainly the hydraulic considerations are the pressure drop, flow distributions, and prevention of the black flow. All right. So if we look into the design parameters and the operational aspects, so the main design parameters are the filtration rate, that is the loading, the amount of what do you call, the gray water or the infiltrate, you know, the water that inflow of water particularly, so that is the filtration rate. So the main impact is to, it directly influences the particle removal efficiency and head loss development, and the higher rates also can lead to the shorter filter runs and reduce the effluent quality. The main selection of these criteria are, the design parameters are mainly selected based on the raw water turbidity, particularly turbidity as in the cloudiness of the water, and particle size distribution, and effluent turbidity, and filter media characteristics, that is so based on the turbidity of the water, based on the contamination of the water, the media characteristics will be decided for its effective size, uniformity coefficient, available head loss, and all that, the amount of head present, and economic considerations as well, whether the capital cost and the operational costs also can be considered. The typical range to select a different kind of media bed, that is pore size, whatever size, granularity, and everything majorly ranges from 4 to 15 meters per head. It is mainly can vary based on the specific applications and source water quality, and the filter media characteristics as well, where effective size, that is it mainly represents the sieve size that allows 10% of the media to pass, and smaller effective sizes generally provide a better particle removal, but majorly increases the head loss, and this typically ranges from 0.35 to zero point 0.6 millimeters for sand, and there is a uniformity coefficient, that is D60 by D10, and which indicates the range of grain sizes, and this filter media typically range from 1.3 to 1.7 for sand, and the media depth as well. So we will be looking into the parameters like several things, particularly the characteristics, the depth. Depth is the contact time for particle removal and the biological activity to occur, and the deeper beds generally provide the better removal with increasing head loss, and deeper it also increases the biological activity as well, and more removal of particles as well, and this typically ranges between zero point 0.6 to 1 meter, and the media type and layering. Sand mainly used is the anthracite, garnet, and GAC, and the underdrain system. So the main function of this underdrain system is that to support the filter media and to collect the filtered water, and also it distributes the backwash water as well. So mainly the underdrain systems are of three types, mainly the perforated types, which is widely used and simple and cost effective, and filter blocks, where it provides the uniform distribution and support, and nozzles as well. So main the considerations will be the head loss through the system, and the uniformity of the distribution of water flow should be uniform, and head loss should be minimal or prevented as well, and hydraulic capacity to in order to handle the backwash flow rates. So the backwash system. Yeah. So the backwash system, mainly we will be looking into the backwash rate and the duration. So in how the flow rate, particularly backwash, the amount of flow or the flow regime used in order to remove the contaminants from the soil media, and also the backwash duration. So the period of time taking place in order to remove or clear the filter bed is the backwash duration, and other one is the operational aspects, where the backwashing procedures, head loss monitoring, turbidity monitoring, filter ripening, operational control and automation, maintenance and troubleshooting, all these will be other operational aspects which has to be looked. And this is main filtration process of rapid sand filtration, where as you can see here, there will be a raw water channel. The water will be sent here, and then the water will be allowed to flow through the sand layer. All right, this is the typical sand layer bed rapid sand filter, where through which the water is forced to get into the media and eject out of this media, and then it goes into the treated water channel. So this is how the treated water channel is, like where the water is getting treated here, and this would after this there is a place where the backwashing goes. There the storage of water, where the water is stored, through which the water is pumped. All right, the water is pumped through the filter media. This is like again the backwashing is called, and yeah. So this is the backwash process, where the water is performing in a reverse mode, that is in the filtration from top to bottom, and for the backwashing process it is from the bottom to top, where from the bottom since it is a media bed, where the water is backwashed in order to clean the media bed, and and that is how the it is collected, the drainage is collected, and the clear water is also collected here, and this is how the filtration of rapid sand filtration occurs. And coming to the slow sand filtration unit, and during the slow sand filtration, it is a water purification method, just like rapid sand filtration method, and this utilizes a biological process in order to clean as it passes slowly through the bed of sand. It is a time tested technique because it is time taking one, which is mainly valued for its simplicity, effectiveness, and especially in removing the pathogens. So, in since it takes a long time, all right. So it is taking since it takes long time for the filtration process in the sand. There is a formation of biofilm, and also there is a formation of microenvironment there, where microorganisms plays a major role. And so since microorganisms plays a major role, there will be a biological process going on, and where slowly it breaks down the organic substances. All right, and it is mainly, if you look into the overview, it is very simple and reliable technique. The slow sand filters are known for its straightforward design and reliable operation, and they require minimal mechanical parts or the chemical additives, and mainly the biological process plays a major role, which is a key to slow sand filtration of development, and biological layers called Smith's kits on the surface of the sand bed. So this layer mainly contains a complex community of microorganisms which break down the impurities. This slow filtration rate, there is a slow filtration rate where the water slowly flows through the sand and allows ample time for the biological purification, where mainly the microorganisms play a key role in this, in breaking down the organic contaminants. And applications where mainly it is suitable for the smaller communities, rural areas, and developing countries, and effective for the treating water with relatively low turbidity. So high turbidity, it will take quite a lot of time for the infiltration purposes. So it is not suitable for the gray water and all, and a very minute turbidity